All right, so yesterday, all you had to do for the entire class period, and then for homework if you needed to, was to finish the pages 15 through 20 in your chapter 1 packet. And today, all I want to do is just go over those. So we'll start, and I want you guys to let me know if you have any questions. I'm gonna also kind of like key in with some really important facts that you need to know for the test, which I'm planning on Tuesday. So again, always read all of the words. So you're basing 1 through 3 on the diagram below. Object A is a solid cube of uniform material having a mass of 65 grams and a volume of 25 cubic centimeter. The key is that it's uniform material. That means it's the same throughout this whole thing. So the density of the material in cube A is determined at different temperatures and phases of matter. At which temperature and at which phase of matter would the density of the cube most likely be the greatest? Before you answer this, what is the key piece of information about density that you need to remember? In fact, that's only true if you don't change the temperature and pressure, but here it said we did change. Nope, everybody. It increases or decreases with heat. That's perfect. Here's what I want you guys to do. So again, since this is kind of not just your homework, but it's also notes, I want you to put a little note here. Density. Does density go up or down when you make things colder? Down. Density goes down when no, it doesn't. Density goes up when it gets, colder. I know I heard both answers and then just got stuck in my head. Density goes up when it gets colder. Remember, things pack together when it gets colder, so they'll be more dense. Knowing that density goes up when it gets colder, which one of these is going to most likely have the greatest density? 1. So by the way, everything that I write in these margins here is going to be something you're going to want to remember for the test on Tuesday. All right, if cube B is removed from cube A, the density of the remaining part of cube A will stay the same. What's the key fact that you need to remember there? Remember, I shouted it out. Size does not matter when talking about density. So if you're confused on that, let's talk about it, because it doesn't depend on who you ask. It does not change when you cut something in half. So are you confused about that, Tyler? Or was that Connor? You didn't say nothing? Okay, that's what I thought. So make sure you got that clear. And question 3, the mass of cube A is measured in order to determine it and calculate its density. The cube has water on it while it's being measured. How would the calculated value of density compare to the actual density? So if we had water on it when we were weighing it, will that mess up the density? What calculation? When you do the math. If you were soaking wet out of the pool when you got on a scale, would that change anything? Yeah. Only the calculated value. Yes, for real, it's going to mess it up. So it's not going to stay the same. The water will mess it up. The water will make the mass heavier. Density equals mass over volume. So the water will make the mass bigger than it's supposed to be. If that top number is bigger than it's supposed to be, what will the density be? Yeah, the density will also be greater. So that's just kind of walking you through like mistakes kids could make when they're doing a lab, which by the way, we're going to be doing this in lab in the next couple of days. Base your answers to questions 4 through 6 on the diagram below, which represents a solid material of uniform composition. What is the mass? So again, you need to remember the magic triangle. What goes on top? M is on top for the magic triangle. And then it doesn't matter where V and D go, so I just switch this around, but M is the only one on top. So they give us the density. So if we're doing mass, we cover up the M, you're left with V next to D. So they give you the density of 2.7, but we still defined the V here. If they give us these measurements, how do we find volume? Yep, so you might want to put that here. Volume equals length times width times height. So we take, and don't add them, multiply it. 2 times 3 is 6, times 2 is 12. So 12 times 27 should give us, sorry, not 27, 12 times 2.7 should give you 32.4. Answer 2. Question 5, when this material is heated and expands, the material will. What happens to the density? When you, I couldn't hear you. Decrease, yep. Density goes down when heated. If they spread out, then they're not as tightly packed together, so they're less dense. So we've got, so which graph best represents the relationship between mass and volume of various size particles of this material? Volume is how big it is. Mass is how much it weighs. So if we read this, we want the x-axis is always going to be increasing. So as volume increases, so as the material gets bigger, what's going to happen to the mass? It'll weigh more. If you have a small piece of a statue, it's going to weigh a little bit. If you have a giant piece of the statue, it's going to weigh a lot. That's answer 2. Water. Remember, water is the exception to the rule. The key that you need to remember for water is most dense at a liquid or as a liquid at 3.98 degrees Celsius. So we're cooling from 4 degrees to 0 degrees. So it's getting colder. But what is so fancy about 0 degrees Celsius? Who knows? Anybody know what happens at 0 degrees Celsius? It's freezing. So we're going from a liquid to a solid. What happens to the density of water when it freezes? It decreases. It's the only one, the only material. It's the exception to the rule. Water is less dense as a solid than it is as a liquid. As the volume of air, so now we're going back to air, expands due to heating, the density of the air will decrease. Hot air balloons rise because they are less dense. Water has the greatest density at approximately, I actually just wrote this at the top of the page. liquid. Answer 4. Student measured the mass and the volume of the mineral crystal below and recorded in the data table below. The student used the data to calculate the density of the crystal. What is the density according to the student's data? So density equals mass over volume. So we get 80 divided by 32, and you should get 2.5 for that. With question 12, what is really important to know with question 12? And in fact, I think Jonah asked this question yesterday. We're dropping us, yeah. Oh, no, there's no 11. Sometimes I make mistakes. Jonah, do you remember what you asked about something sinking in liquids? What do we need to know to answer this question, guys? If the density, I couldn't hear the density of an object is lower than the density of the liquid flowing into the substance. And vice versa. If the density is more than the liquid it's going into, it will sink. So it works with ice and water. So ice has a density less than that of water, so it floats. So this one, we're dropping a piece of quartz with a density of 2.7 into these liquids. Will it float or sink as we go into W? Sink. As we go into the X? Sink. Y? Z? Float. So we need one that says it's going to go through all of them except for Z. That's answer 3. The quartz release, it will pass through W, X, and Y, but not Z. Guys, question 13 is always, 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 always on the test. And it will be throughout the year as well. It says, which graph represents the relationship between density of a substance and its state of matter for most earth materials, excluding water? So we're not talking about water. What did we say on page, we would have put it right here on page 14. I didn't write the notes in this packet. Which phase of matter is the most dense? Solids. Solids are most dense. So that right away says it's not answer 1, it's not answer 2, or I'm sorry, it's not answer 4. So who's going to be the least dense, liquids or gases? Gases are least dense. Answer number 2. I had a lot of people ask me, do I have to fill in these spots here for this next question? You got to do whatever the directions tell you to do. So it says the data table below shows the mass and volume for 3 samples of 2 different materials. The density of water has been plotted. Part 1 says plot the 3 samples of material A and draw the line to illustrate its density. And 2 says plot the samples of B and draw the line to illustrate the density. Do you have to write them in? According to the directions so far, you do not. Don't screw this up. We have a mass of 14. Mass is on this side. So mass of 14 and a volume of 8. That's there. A mass of 35. A volume of 20. If you do these lines in the background on your lab, that's fine, or on your paper, that's fine. And then 21 and 12. And you would connect these 3. You could take it all the way down to 0, 0, because if we had a mass that was 0, you'd have a volume that was 0. This is material A. Material B, again, don't mess this up. Mass is on top, volume's on the bottom, so 8 and 20. 12 and 30. And 4 and 10. We would have had to have those lines on there. Now it says, what's the material, the density of material A? So you do have to go back up. And do the density. Now, did you have to do the density for all three of these? They should all be the same because it is the same uniform material. So 14 divided by 8 is 1.75. 35 divided by 20, 1.75. Or 21 divided by 12, 1.75. So that was just to prove a point. You did not have to do them all. What's the density of material B? Again, you don't have to do them all, just do one of them. So 8 divided by 20, 0.4. What did you do? And you did it wrong because it's mass divided by volume. Yep. So always remember that density is mass over volume. And just plug those in correctly. Now, careful when answering question 6. It says referring to the line graph. So here's the line graphs. How can you tell that material A is, or tell if a material is less dense? Which one of these is less dense than water, A or B? B, yep, because it had a density of 0.4. How could you tell by just looking at the line graph that it's, yes, the line is lower than the line for water. How can you tell if it's more dense? The exact opposite. The line is higher than the line for. And then finally, the greater the density, the blank the slope. The higher, the bigger, the greater, either one of those words. And you can tell because this has a bigger density, so it has a greater slope. So questions on page 18. So it says answer the following questions for each sample below. Each sample is made of the same uniform material. If it's got the same uniform material, what else do you know? Same density. That is the key. Same uniform material has the same density. So you start off doing the volume and it tells you volume is length times width times height. 2 times 2 times 2 is not 6, it's 8. Then you do the density equals mass over volume. They tell you the mass was 24 grams. We just did the volume of 8 centimeters cubed. That gives us a density of 3 grams per centimeters cubed. Then we do the volume for this one. Volume equals 3 times 2 times 1, which equals 6. Now, using the magic triangle, DMV, if I want to find the mass, it's density times volume. So we know the density was 3. We just found the volume was 6. That's 18 grams now. And then you got to do the same thing over here. What's the mass over here? So mass equals density times volume. We know the density is 3. They tell us the density or the volume is 12. So in this case, we get 36 grams. Then you just had to plug that information down here. So we start with mass of 24 right from here. We found the volume of 8. Here we found the mass was 18. We knew the volume was 6. And we have a mass of 36 and a volume of 12. Plot those numbers. Again, mass is on the X. So 24 and 8. $18 and 6. $36 and 12. Here's the line. Yes, you could have done a better job connecting it than I just did. Determine the density of each sample. So the data table below shows the mass and volumes of 3 samples of the same mineral. Mass divided by volume, 50 divided by 25 is 2, 100 divided by 50 is 2, and 2. Now be careful here. Now we've got the volume and the density. So that's these two. Volume and density. What happens is volume increases. Density stays the same. That's answer 3. According to this next one, we're going to use this for 10 through 12. What's the density of material Y? So the easiest way to do this is mass divided by volume. So you pick any mass. I'm going to pick a mass of 30. So if I have a mass of 30, what's my volume? So remember, if we're looking for density, we have mass divided by volume. I picked a mass of 30, and according to the chart, when it's 30, the volume is, was that 6? Yeah. So that equals 5. Answer 3. And then for Z, it says when the volume of material Z is 14 cubic centimeters, its mass must be. So we just need to go to 14 cubic centimeters, go up till you hit the line for Z, read over, and I got halfway in between-ish, so I can tell, so I would have said it was 15. Apparently 15 is not the answer. So is it 15 or 16? Is the line at all above the 15 mark? No. So I'm going to go with it's 14. And then it says using the graph above, draw the line for the material who has a volume of 7. So here's 7 and a mass of 12. So volume of 7, go up to a mass of 12. That would put a dot right there. And all you had to do was draw the line. Again, you should have probably hit the line, and like I just did. And you had one more page. Some of these were actually all super easy. Mass divided by volume, you should have got 2.65, 1.0, 0.1, 2, 3, 4 zeros and a 9, and 2.3. So then put them in order from least to most. So the smallest is going to be D. Then the next smallest is, oh, I forgot about, I'm sorry, I skipped A up here. Mass divided by volume, is that 0.5? No, okay. So mass was 10, volume was 20, so that's 0.5. So sorry, I skipped A and then C, E, and then B. What is 0.5? What is the density of water? That's either straight from your notes or out of your reference table. It's 1 gram per milliliter. So which one would float if it was put into water? C, did you say? A definitely would. What other one definitely would? D. I would accept C as well because it's the same. But technically, think about putting a water balloon in a pool. Does a water balloon really float? Or does it kind of hover in the middle? Doesn't float like something filled with air would float. What happens to the volume of air if it's heated? Yep, the volume gets bigger, so it increases. So when you heat up air, the volume increases. What happens to the density though? Decreases, because if it's spread out, If it's spread out, then it's less tightly packed. What happens to the volume of material if it's put under pressure? Yep, if you put pressure on something, it gets smaller, so then what happens to its density? Its density, if you put pressure on something, increases, it's more tightly packed. Oh, sorry. So the key here is the sentences as temperature increases. What happens to, as temperature increases, what happens to volume? Oh, yep, increases. And what happens to density? Okay, so those are really important. That is it for today. You do have homework though. 21. Page 21. I think I'm gonna move the test to Monday too. I was confused and I really thought when I wrote that yesterday was Thursday.
Why Monday test? Monday test is not with it.
Monday tests are not with it, and Tuesday tests are just that much better.
Yes.
If we do the test on Tuesday, we're gonna start new stuff on Monday.
But like, when I was a weekend, I'm gonna forget what happened outside.
So don't. Because you're still, I'm not gonna continue to review, I'm just gonna do new stuff that's not going to be on the test.
Monday should be a review.
But then what are we gonna do tomorrow?
I don't see nothing.
Yeah, that would be nice, but
Tomorrow's quick, reviewing Thursday, Monday should be a review, Thursday.
we don't have that much reviewing. The chapter wasn't that long. Do the homework. I believe I have a game to play then on Monday, or Friday, tomorrow, whatever day is coming up.